Hello guys, my name is Hans Jalola from AMT1 Alpha, and today I am going to discuss corrosion. So let's start. So what is corrosion? Corrosion is a natural process that converts a refined metal into a more chemically stable form such as oxide, hydroxide, or sulfide. It is a gradual destruction of materials, usually a metal, by chemical and electrochemical reaction in their environment. So corrosion is an electrochemical reaction that appears in several forms, such as chemical corrosion and atmospheric corrosion, the latter of which is the most common form. So, how corrosion occurs? Corrosion occurs when acidic substances, including water, come in contact with metal, such as iron and steel. Rust begins to form. Rust is the result of corroding steel after the iron, or Fe, particles have been exposed to oxygen and moisture. When steel is exposed to water, the iron particles are lost to the water's acidic electrolytes. The iron particles then become oxidized, which result in the formation of Fe. When Fe is formed, two electrons are released and flow through the steel to another area of the steel known as cathodic area. So oxygen causes these electrons to rise up and form hydroxyl ions. The hydroxyl ions react with the Fe, or iron, to form hydrous iron oxide, better known as rust, where the affected iron particles where has now become a corrosion pit, and where they are now is called a corrosion product. So corrosion can happen at any rate, depending on the environment that the metal is in. However, since atmospheric corrosion is so widespread, it is recommended to take effective precautionary measures when it comes to corrosion prevention. So these are the factors which affect corrosion. The main factor which affect corrosions are the following. Number 1. More the reactivity of metal, the more will be the possibility of the metal getting corroded. Carded. 2. The impurities help in setting up voltaic cells, which increase the speed of corrosion. 3. Presence of electrolytes in water also increases the rate of corrosion. 4. Presence of CO in natural water increases rusting of iron. 5. The iron surface is coated with layers of metals more active than iron when the rate of corrosion is retarded. 6. A rise in temperature within a reasonable limit increases the rate of corrosion. So, the corrosion of steel in carbonated mortar has been investigated by monitoring polarization resistance, corrosion potential, and mortar resistivity. The results suggest that factors such as relative humidity and chloride contamination affect the corrosion rate via their influence on mortar resistivity. So there are two classifications of corrosion which cover the most of the specific forms. These are the direct chemical attack and the electrochemical attack. So let's start with the direct chemical attack. So direct chemical attack, or pure chemical corrosion, is an attack resulting from direct exposure of a bare surface to caustic liquid and gaseous agents. Unlike electrochemical attack, where anodic and cathodic changes take a place measurable distance apart, the changes in direct chemical attack occur simultaneously at the same point. Let's say the most common agents causing the direct chemical attack on aircraft are spilled battery acid or fumes from batteries, residual flux deposits resulting from inadequately cleaned, welded, braced, or soldered joints, and entrapped caustic cleaning solutions. So this is electrochemical attack. Electrochemical attack. Corrosion is a natural occurrence that attacks metal by chemical or electrochemical action, converting it back to a metallic compound. The following four conditions must exist before the electrochemical corrosion can occur. 1. A metal subject to corrosion, which is anode. 2. A dissimilar conductive material, which is cathode, that has less tendency to corrode. 3. Presence of a continuous conductive liquid path, which is electrolyte. 4. Electrical contact between the anode and the cathode, usually in the form of metal to metal contacts such as rivets, volts, and corrosions. So, in both types of corrosion, the metal is converted into a metallic compound such as an oxide, hydroxide, or sulfate. The corrosion process always involves two simultaneously changes. The metal that is attacked or oxidized suffers that may be called anodic change and may be considered as undergoing cathodic change. Types of corrosion. So there are several types of corrosion, and the science and understanding of this process are constantly evolving. Here is a brief overview of some common types of corrosion: galvanic corrosion, pitting corrosion, microbial corrosion, high temperature corrosion, and crevice corrosion. So let's start with the galvanic corrosion. Galvanic corrosion, the most common and the impactful form of corrosion. It occurs when two dissimilar or different metals are in contact with the presence of an electrolyte. Pitting corrosion. Pitting corrosion occurs under certain conditions which led to accelerated corrosion in certain areas rather than uniform corrosion throughout the piece. Such conditions include low concentrations of oxygen or high concentration of chlorides that interface with the alloy's ability to reform a passivating film. In the worst cases, most of the surface remains protected, but tiny fluctuations degrade the film to a few critical areas. Microbial corrosion. Microbial corrosion, commonly referred to as microbiologically influenced corrosion or MIC, is caused by microorganisms. It applies to both metallic and nonmetallic materials, with or without oxygen. When oxygen is absent, sulfate-reducing bacteria are active and produce hydrogen sulfide, causing sulfide stress cracking. When oxygen is present, some bacteria may directly oxidize iron to iron oxides and hydroxides. Concentration cells can form in the deposits of corrosion products, leading to localized corrosion. So, high temperature corrosion. As its name suggests, is deterioration of a metal due to heating. This can occur when a metal is subjected to a hot atmosphere in the presence of oxygen, sulfur, or the other compound capable of oxidizing material. Surface corrosion. Surface corrosion occurs in confined spaces where access of fluid from the environment is limited, such as gaps and areas between parts, under gaskets or seals, inside cracks and seams, and spaces filled with deposits. Galvanic series. The galvanic series determines the electrochemical potential and ability of metals and metal alloys. So when two metals are submerged in an electrolyte while also electrically connected by a metallic conductor, the less noble will experience galvanic corrosion. The less noble metals becomes the anode and corrodes faster than it would all by itself. So while the other becomes the cathode and corrodes slower than it would alone. So this galvanic series chart. The chart can be used to determine the likelihood of a galvanic reaction and galvanic corrosion or bimetallic corrosion between two different metals in a sweater environment. So the closer a metal or an alloy is in the galvanic series, the less are the effects of the galvanic corrosion compared to those metals far apart. So, galvanic series chart shows metal and their electrochemical voltage range, so relative activity in flowing seawater. So that was the end of my topic. Thank you for listening, and I hope you learned something in my discussion. Thank you.